66 million years ago, something killed 75% of all life on Earth in what might be the most famous cold case in history. But here's what they didn't tell you in school. The asteroid wasn't the only killer. We're counting down the 16 forensic clues that reveal the real timeline of the dinosaur extinction, and some of them will completely change what you thought you knew about that day. In 16th place, shocked quartz crystals, the geological equivalent of gunpowder residue at a crime scene. These microscopic grains of quartz show a distinctive deformation pattern that only occurs under extreme pressure, the kind generated by asteroid impacts or nuclear explosions. Geologists discovered shocked quartz in a thin layer of sediment marking exactly when dinosaurs disappeared from the fossil record. And it's not just in one place. It's global, from Montana to New Zealand, from the Gulf of Mexico to the North Sea. The forensic signature is unmistakable. Something hit Earth with enough force to vaporize rock and scatter the evidence worldwide in a matter of hours. This wasn't death by volcano, climate change, or bad luck. This was death by cosmic bullet. And the shocked quartz is proof that even rocks couldn't believe what they were seeing. But if the evidence is this clear, why did it take scientists nearly 150 years to figure it out? The answer to that is coming up. Number 15. The iridium layer, nature's crime scene tape wrapped around the entire planet. In 1980, physicist Luis Alvarez and his son Walter discovered something impossible. A thin layer of clay at the Cretaceous-Paleogene boundary containing iridium levels 30 times higher than normal. Here's why that matters. Iridium is extremely rare in Earth's crust but abundant in asteroids. Finding it concentrated in a single global layer meant only one thing: something from space delivered it. The iridium spike isn't a local anomaly or a measurement error. It's been confirmed at over 350 sites worldwide, from Italy to New Mexico, from Denmark to New Zealand. Chemical analysis shows the iridium came from a chondrite asteroid, the most common type in the solar system, and the concentration is consistent with an impact from an object roughly 10 kilometers wide. For the first time in history, paleontologists had physical evidence linking an extraterrestrial event to a mass extinction. But iridium alone wasn't enough to convince everyone. The real smoking gun was still buried under half a mile of ocean and jungle. Number 14. Tektites. Tiny glass spheres created when rock vaporizes on impact and rains back down as molten droplets. These aren't just any glass beads. They're forensic fingerprints. Tektites from the Cretaceous-Paleogene boundary have been found across North America and the Caribbean, and their chemical composition matches the limestone bedrock of the Yucatan Peninsula in Mexico. Geologists traced the trajectory of these glass spherules backward, and they all pointed to one location: a massive buried impact crater near the town of Chicxulub. Chicxulub. The tektites tell a horrifying story. Within minutes of impact, vaporized rock shot into the upper atmosphere, cooled into glass, and rained back down across thousands of miles. Still hot enough to ignite forests on contact. Some tektites show layering, proof they partially solidified mid-flight before melting again during re-entry. This wasn't just an explosion. This was a planetary-scale blowtorch, and we haven't even gotten to the tsunami yet. Number 13. Tsunami deposits in the Hell Creek Formation provide proof that the impact sent walls of water crashing inland hundreds of miles from the coast. Sedimentologists discovered chaotic layers of jumbled marine fossils mixed with terrestrial sediments in Montana and North Dakota, over 2,000 miles from the impact site. The deposits show clear signs of high-energy water flow, cross-bedding, rip-up clasts, and shocked quartz mixed with marine microfossils. Forensic analysis of the sediment reveals multiple wave surges, consistent with a mega-tsunami generated by an asteroid impact in shallow water. Computer models estimate wave heights exceeding 1,500 feet at the impact point, diminishing but still catastrophic. As they traveled inland through the western interior seaway that once split North America in half. Fossils preserved in these tsunami deposits include fish, turtles, and even a few unlucky dinosaurs caught in the wrong place at the worst possible time. The water didn't just drown them, it buried them so quickly that scavengers never touched the remains, giving us some of the best preserved fossils from the day the world ended. Number 12, the Deccan Trap's volcanic ash layers, evidence that Earth was already in crisis before the asteroid hit. For over 30 years, geologists have debated whether the massive volcanic eruptions in India contributed to the extinction or were just a terrible coincidence. Recent high-resolution dating has settled the debate. The volcanism started about 400,000 years before the impact and continued for another 500,000 years afterward. But here's where it gets interesting. The Deccan Traps weren't just erupting lava. They were pumping sulfur dioxide and carbon dioxide into the atmosphere at rates that would make modern climate change look gentle. Chemical analysis of marine sediments shows temperature swings of up to 2 degrees Celsius in the million years leading up to the impact, consistent with volcanic climate disruption. Paleontologists examining dinosaur fossils from this period have found increased pathologies, stress fractures, and signs of malnutrition. The dinosaurs weren't thriving when the asteroid hit. They were already struggling. The asteroid didn't kill a healthy ecosystem. It finished off a patient that was already on life support. But the final blow was still ahead, and it came from above. Number 11. Global soot layers indicating wildfires that burned across continents simultaneously. Within hours of the impact, the ejected material that went into space came back down, still superheated from re-entry. The resulting thermal pulse ignited forests across North America and possibly worldwide. Geochemists analyzing the KPG boundary layer found massive soot concentrations consistent with 15% of Earth's forests burning within days. But it gets worse. The soot wasn't just from surface fires. Isotope analysis reveals the combustion was so complete that even underground peat deposits and coal seams ignited, creating an inferno unlike anything in recorded history. The smoke from these fires would have blocked sunlight for months, maybe years, creating what scientists call an impact winter. Photosynthesis ground to a halt. Plants died. Herbivores starved. And the carnivores that depended on them followed shortly after. The soot layer is thin, rarely more than a few centimeters, but it represents a global catastrophe that unfolded in weeks. For animals that survived the initial impact, the fires, and the tsunamis, the real nightmare was just beginning. Number 10, the pollen record shows a near total collapse of plant diversity immediately after the impact. Paleontologists studying microscopic pollen grains trapped in the KPG boundary discovered something chilling. Above the boundary, the diversity crashes to almost nothing. In North Dakota's Hell Creek Formation, over 30 species of flowering plants disappeared overnight. Their pollen simply stops appearing in the fossil record, replaced by a monotonous layer of fern spores. This pattern repeats globally. In New Zealand, Spain, and Argentina, the story is the same. Plants died en masse, and the base of the food chain collapsed. But here's the forensic twist. The plant die-off wasn't uniform. Conifers and other gymnosperms fared slightly better than flowering plants, probably because their seeds could survive longer without sunlight. Aquatic plants took the hardest hit, which explains why freshwater ecosystems saw extinction rates exceeding 90%. The pollen evidence doesn't just tell us plants died. It tells us when, where, and in what order, giving us a timeline of ecosystem collapse that reads like a coroner's report. Number 9, the fern spike. Proof that only the humblest survivors inherited the earth. Immediately after the plant die-off, one group exploded in abundance: ferns. The pollen record shows a dramatic spike in fern spores in the centimeters above the KPG boundary, sometimes making up over 90% of all plant material. Why ferns? Because they're disaster specialists. Ferns reproduce via spores that can lie dormant for years, and they thrive in disturbed, low-light environments. After the impact, winter killed almost everything else. Ferns were the first to recolonize the barren landscape. This fern spike has been documented globally and serves as a biological marker for the immediate aftermath of the extinction. The pattern is so consistent that geologists use it to identify the KPG boundary in locations where the iridium layer is absent. But the fern dominance didn't last forever. Within a few thousand years, other plants began to recover, and ecosystems slowly rebuilt. The ferns had their moment. Then evolution moved on. Number 8. Marine plankton collapse, frozen in the fossil record. While dinosaurs get all the attention, the oceans tell an even more complete extinction story. Micropaleontologists studying foraminifera, tiny shelled plankton, discovered that species diversity plummeted by over 90% at the KPG boundary. These weren't just a few unlucky species. Entire lineages vanished overnight. The extinction was so severe that it took over 2 million years for plankton diversity to return to pre-impact levels. Why does this matter? Because plankton form the base of the marine food chain. When they collapsed, everything above them followed. Ammonites, marine reptiles, and countless species of fish went extinct in the cascading collapse. Chemical analysis of the plankton shells reveals rapid acidification of the oceans, likely from sulfuric acid rain generated by the impact vaporizing limestone and gypsum. The oceans didn't just lose species, they turned toxic. For marine life, the asteroid impact was a chemical weapon as much as a physical one. Number 7. Size-selective extinction, the forensic clue that reveals who lived and who died. Paleontologists analyzing extinction patterns noticed something strange. Small animals survived at much higher rates than large ones. Any terrestrial animal heavier than 25 kilograms had less than a 5% chance of making it through. Dinosaurs, being mostly large, were doomed from the start. But small mammals, lizards, and birds had survival rates exceeding 50%. Why the size bias? The leading theory is metabolic demand. Large animals need more food, and when the food chain collapsed, they starved faster. Small animals could survive on scraps, seeds, and carrion. They could also shelter underground or in water, protecting them from the initial thermal pulse. Forensic examination of mammal fossils from immediately after the extinction shows dramatic increases in average body size within a few million years, as survivors rapidly evolved to fill the ecological niches left vacant by dinosaurs. The pattern is clear. In the aftermath of catastrophe, being small and flexible beats being big and specialized. Number 6. Mammal survival evidence that explains why we're here today. While 75% of species went extinct, mammals didn't just survive, they thrived. Paleontologists examining the fossil record found that nearly all mammal lineages that existed before the impact made it through. Why? One word: burrowing. Fossils show that most late Cretaceous mammals were small, nocturnal, and lived in underground dens. When the impact winter hit and surface temperatures plummeted, mammals were already insulated. They could wait out the firestorms, the darkness, and the cold. Dental analysis of mammal teeth from this period shows they were dietary generalists, eating everything from insects to plant material to carrion. When the dinosaurs starved, mammals pivoted. Within 10 million years of the extinction, mammals had diversified into nearly every ecological niche on land, from tiny shrews to early whales in the oceans. The forensic lesson here is brutal. Evolution rewards cowardice. The species that hid underground while dinosaurs fought for survival ended up inheriting the planet. Coming into the top 5, And this is where the forensic timeline gets even more disturbing. Number 5. Chicxulub crater dating. The moment science pinpointed the murder weapon. In 1991, geophysicists confirmed the existence of a massive impact crater buried under the Yucatan Peninsula in Mexico. The crater measures 180 kilometers in diameter and shows all the hallmarks of a catastrophic asteroid strike: shocked quartz, impact melt rock, and a central uplift ring consistent with a strike velocity exceeding 20 kilometers per second. But the real breakthrough came with radiometric dating. In 2013, researchers used uranium-lead dating on impact spherules to pinpoint the exact moment of impact, 66.043 million years ago, plus or minus 11,000 years. This is as close to a precise timestamp as geology can provide. The crater's size indicates an asteroid roughly 10 to 15 kilometers wide, traveling at 12 miles per second. The energy released on impact, 100 million megatons, over 1 billion times more powerful than the Hiroshima bomb. This wasn't just an extinction event. This was Earth's worst day in 66 million years. And now, thanks to forensic crater analysis, we know exactly when and where it happened. Number 4. The Hell Creek Formation's last day fossils. Prehistoric Pompeii, frozen in stone. For decades, paleontologists searched for fossils from the exact moment of impact, the geological equivalent of watching the murder happen in real time. They found it in North Dakota. The Hell Creek Formation preserves a nearly continuous record of the last 2 million years of the Cretaceous. And in the uppermost layers, mere centimeters below the KPG boundary, researchers discovered something extraordinary. Perfectly preserved dinosaur fossils with no signs of scavenging, rapid burial, and, in some cases, articulated skeletons. These animals didn't die slowly over thousands of years. They died suddenly and were buried immediately. One Triceratops specimen discovered in 2019 shows impact debris embedded in its bones, proof it died within hours of the asteroid strike. CT scans of the bones reveal stress fractures and pathological growth, suggesting the animal was already in poor health when the impact occurred. The Hell Creek fossils don't just tell us dinosaurs died. They tell us they were struggling even before the final blow. Number 3. Fish fossils with asteroid debris in their gills. The discovery that changed everything we thought we knew. In 2019, paleontologist Robert De Palma announced the discovery of a fossil site in North Dakota that preserved the first hours after the Chicxulub impact in unprecedented detail. The site, known as Tanis, contains fish fossils with impact spherules lodged in their gills, proof they inhaled the debris as it rained down from the sky. Amber from the site contains microtektites chemically identical to those found at other KPG boundary sites, and the sediment shows signs of seismic shock waves consistent with a magnitude 10 earthquake triggered by the impact. The fish didn't die from starvation or climate change. Weeks later, they died within hours, maybe minutes, of the asteroid strike, choked by glass spheres falling from the sky. The Tanis site is the closest thing paleontology has to a snapshot of the apocalypse. And it confirms what forensic geologists have long suspected. The extinction wasn't gradual. It was instantaneous. One moment, ecosystems were functioning. The next, they weren't. Number 2. Dinosaur fossils with pathological stress indicators from years before the impact. For over a century, paleontologists assumed dinosaurs were thriving right up until the asteroid hit. That assumption is dead. Recent analysis of dinosaur bones from the final million years of the Cretaceous reveals widespread evidence of stress, disease, and malnutrition. Hadrosaur fossils from Montana show unusually high rates of bone infections and fractures that healed poorly, indicating immune system suppression. Ceratopsian specimens from Alberta display signs of vitamin deficiencies and growth disruptions. Even apex predators like Tyrannosaurus show pathological bone growth consistent with long-term stress. The culprit? The Deccan Traps volcanism. For hundreds of thousands of years before the asteroid, Earth was experiencing climate instability, acid rain, and temperature fluctuations that weakened ecosystems. Dinosaurs weren't killed by the asteroid alone. They were killed by a 1-2 punch, volcanic stress, followed by cosmic impact. If the asteroid had hit 500,000 years earlier, when ecosystems were healthier, some dinosaurs might have survived. But it didn't. It hit at the worst possible moment, when life on Earth was already on the edge. And finally, in first place, the double whammy theory that reveals the ugly truth about extinction. Timing is everything. For decades, scientists debated whether the asteroid or the Deccan Traps volcanism killed the dinosaurs. The answer, as forensic evidence now makes clear, is both. The volcanic eruptions destabilized ecosystems for hundreds of thousands of years, causing climate swings, acid rain, and food chain stress. Dinosaur populations declined, biodiversity dropped, and resilience weakened. Then, at the worst possible moment, a 10-kilometer-wide asteroid struck the Yucatan Peninsula with the force of 1 billion nuclear bombs. The combination was catastrophic. If only the volcanoes had erupted, life would have recovered, just as it had from previous volcanic crises. If only the asteroid had hit, healthier ecosystems might have absorbed the shock. But both together, in rapid succession, created a perfect storm of extinction. 75% of all species vanished, including every non-avian dinosaur. The forensic evidence is undeniable. The dinosaurs didn't die from one cause. They died from a conspiracy of disasters, each one amplifying the other until the entire biosphere collapsed. From the microscopic shocked quartz crystals that proved an asteroid struck Earth to the double catastrophe theory that explains why nothing survived, these 16 forensic clues have solved the greatest cold case in natural history. The dinosaurs weren't just unlucky. They were victims of the worst timing in the history of life, caught between volcanic hell below and cosmic fire above. Every fossil, every chemical trace, and every sediment layer adds another piece to the story, transforming bones into testimony and rocks into witnesses. The extinction wasn't instant, and it wasn't simple. It was a cascade of disasters that unfolded over hundreds of thousands of years, culminating in one terrible day, 66 million years ago, when the sky caught fire and the world ended. Dinosaur forensics has done more than solve a mystery. It's given us a warning. When catastrophes stack, nothing survives. And if you found this investigation as fascinating as we did, we'd love for you to stick around for more. Hit that subscribe button, because next time we're uncovering the survivors, the species that crawled out of the ashes and built the world we live in today. Thanks for watching.